So we're continuing our functional groups. Now, remember, Thursday you have a quiz, so we want to get through as many of these as we can today. Also remember that I'm supplementing your book a little bit because I'm trying to build some bridges from before and after. Is anybody absent today?
I think some of the boys are just trying to come back from PE.
That's what it is? Okay. All right. So we're going to start out with where we left off, and we're going to look at an aromatic group. An aromatic functional group, you'll find that a lot of these are going to get the name because they are aromatic. What does the word aromatic mean?
I have no idea. Doesn't it have like a strong smell?
Yes. Okay. So these, you will find that these will have, a lot of them will have a smell, and it's associated with this particular functional group. Okay. Now, an aromatic functional group is going to one, two, three, four, five, six. Yes? Okay. Okay. An aromatic functional group is, in your book, it is drawn in this way with alternating double bonds. I need you to understand that you will very frequently see it drawn this way with a circle in it. Okay, you need to get used to that. And the reason that it has a circle in it is because, remember, electrons can become delocalized, meaning that they do not have to stay in one place. And so whenever you have some structures that contain double bonds, sometimes those double bonds shift between certain carbons. And so the concept of drawing the circle here is showing that those electrons are actually kind of going around and being shared by all of those carbons. When we do structures, a lot of these things are going to be much more easy to see when we do structures, but right now, remember, we're just getting an introduction to what these functional groups are, and I'm just pointing out some of the main little things that you need to look out for whenever you're doing this. Okay? So this particular functional group is called benzene, and it does not have a particular ending that is associated with it, but you're going to see benzene rings very, very, very frequently. So when we look at, remember, I'm making that bridge between the empirical formulas and molecular formulas that we did last semester, because we're still going to be doing them in subsequent chapters. But
any juniors that need to see Johnson's about your ring being resized, please come to the high school office. Thank you.
okay, so I'm trying to go ahead and include them here so you remember them from last semester, and then this semester when we run into them again, you're not forgetting them. Okay, so I don't want to do this completely in isolation. But let's go ahead and look at what your molecular formula for this would be. You'd have 1, 2, 3, 4, 5, 6 carbons, and you would have a hydrogen sticking off of each one of them, so you'd have 6 hydrogens. 1, 2, 3, 4, 5, 6. This would be your molecular formula. Now, what would the empirical formula be?
CH.
Plain old CH. Now, this particular thing, there's an interesting story behind it. but it's a compound that puzzled chemists for a while, and they were trying to draw the structure, and they didn't quite know how to draw that structure.
Jimmy, just take this one.
So a chemist called Alkyl was working on this and trying to figure out just how in the world, what does this structure look like? And it actually, sometimes in our subconscious mind we sort things out. This kind of actually came to him in a dream. He started dreaming about a snake chasing its tail and biting its tail, and that's how this became a feasible. And they started looking at this as actually being a feasible structure, and that's what it was. But it is a very interesting story. Okay, the next thing is an alkyl halide. What does the word halide remind you of from last semester? Halogens. Remember, your halogens are your salt formers. We will represent halogens by using an X. Okay, so your X could represent a chlorine, fluorine, bromine, iodine. It could represent any of those halogens. The example that they give you is, well, first of all, an alkyl halide is represented in this way. Now I'm going to start doing something here that your book does not do at this point, but it will do later on. And I'm going to start, and I'll do both of them until you get used to seeing it. But understand, what we're worried about here, what we want to focus on, is this functional group right here. Whatever comes before it is not of main concern to us right now. And often in organic chemistry, at this level, we don't really care at all about what comes before it. When we do reactions, we just want to look at the functional group. So and if you think back to your biology days, you dig up some of those biology notes, you take out a biology book, you're going to see that the letter R is used. R represents whatever comes before that is not a part of the functional group. Okay, so R is the stuff that is being abbreviated. Just like whenever you all did electron configurations, it got to be very repetitive, writing 1s2, 2s2, 3s2, blah, 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 right? And so instead of rewriting out all that stuff, we wrote the noble gas configuration, and we just used that noble gas to represent the stuff that came before it. So I'm going to do it both ways to give you all a little opportunity to see until you get comfortable with only seeing it one way. Alright, so the example that they give you of an alkyl halide is ethyl chloride. Now, if you look at medicines, you'll see a lot of medicine labels are going to have halogens at the end of them. And all the I'll just have to bring in some of my numerous pill bottle boxes later and have y'all look at them. But you'll see that they have like chlorides at the end, or fluorides at the end, or whatever. And that's an example of an organic halide. All right, I'm going to start pointing out something else to you that I'll be doing. Your book does it too, but it's more obvious when I do it than when your book does it. That is with the line structures. Notice that it can be a little bit confusing to an untrained eye. If you take a look and put your finger on this line structure for ethyl chloride in your book, and then go ahead and move your finger up to the very first alkane that we looked at, which was propane. So let me show you where some confusion could possibly be introduced, and something that I do, and the book does it, it just doesn't do it as drastically as I do it, to help myself eliminate a little of that confusion. Remember, at the end of each of this line segment here, at the end of that, each end of the line segment is a carbon. So we got a carbon here, we got a carbon here. It could be very easy to mistake the end of this line segment for a carbon. Do you understand what I'm saying?
Not making a carbon, you're trying to show us.
No, I'm just showing you where the carbons are. Notice your line structures do not have any dots. I'm just trying to remind you that the end of each line segment is a carbon. So like if you look up at the very first one, this is propane. That's the line structure for propane. Now take a look at this. Can you see how a person could possibly think there were 3 carbons there? Okay. The one thing that I do is I'm showing a little bit shorter line here. And the other class asked me, why does yours look different from what's in the book? Well, I make those lines a little bit shorter than the book does, probably, is one reason. And then another reason is because, remember, the book makes perfect angles. It has computers to make things just right in certain lengths. And so you're going to naturally, when I draw them or when you draw them, it may not look exactly like the book. Okay. But do you see 2 carbons and then the chlorine at the end? Now, again, we're going to go ahead and look at our molecular structure, our molecular formula. I've got C2H5. Cl. So now this would be a molecular formula. Would the empirical formula be any different? Okay, so both of these would be the same. All right, so we've got an expanded kind of formula here. We've got a line structure here. Lots of different representations. Yes?
How do you know there was 5 hydrogens?
3, 4, 5.
Oh, I didn't know what you were saying.
Okay.
Yes, ma'am.
Yes.
What's that thing right there where the C and the X's and R's? What is that?
Here? Okay. Do you have your book with you?
Yeah, ma'am.
Okay. If you put your finger on the alkyl halide, this one should look just like the one in the book, right?
Yeah, ma'am.
Okay. Now, you're going to begin to see me using the R, because that's going to be something that you're going to see frequently. Remember, we care about the functional group. That is the main point.
So that's the functional group?
The X is the functional group. That's what I care about. Do you need to know anything?
I'm gonna go finish some stuff Mr. David's room.
Okay.
Thank you.
You're welcome. And so, in order to make my life easier, just like I did whenever I was doing electron configurations. Remember how writing out 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. You remember how repetitive that is?
Yes, ma'am.
Okay, same thing here. Because especially when I start to do organic reactions, this is what I care about here. All this other stuff, I really don't care about it.
So in the book, all the functional groups are things red.
Yes.
So that's what our quizzes are. Thursday?
It will include knowing your functional groups, okay, I'll take however many questions, but what y'all need to know is that I've got to keep a certain pace, but I'll take all the questions you want, but whether I get over or not will kind of depend on how long it takes me to answer questions. So go ahead.
Okay, so we need to memorize this for the quiz. This is what it's going to be.
That table, you need to understand
The line structure.
everything. Yes.
Oh, so it's not just the line structure we need to memorize?
Functional groups, line structures. Okay. Okay. So, and then also that, being able to take, if I give you something and turning it into a molecular empirical formula, that's a skill from last semester that you should be able to do. Okay? Now, and I know, and again, I know this is difficult and everybody's going to, feel frustrated. Remember though that organic chemistry, this is going to be a one-class thing. Okay, and then you're expected to know it. So I am taking 3 days for it. And I know that it's painful, but I do need y'all to realize too that I'm stretching it out over 3 days instead of 1 day. Let's take a look at an alcohol functional group. Alcohols are very, very common. We use them all the time. And they're going to end with that suffix OL. Okay, so if you see OL at the end of something, you know that there's an alcohol functional group. Now, an alcohol functional group is going to be OH. That is an alcohol functional group. Your book goes ahead and shows that carbon connected to the OH. Here, I'm just putting the R in here.
So R means
Everything except the functional group. Okay, R means all the other stuff except the functional group. Because the functional group is what is important. This is what causes it to react certain ways and to do certain things.
So everything in the book that's highlighted red, those are functional groups?
Yes. Okay. Now, the example they show you is ethanol. Okay? Ethanol, this happens to be drinking alcohol. CH3, CH2, OH. That is an expanded formula for alcohol. If we were to write the line structure for this, wait a minute, I gave you propanol line structure. Let me, give me a minute. Sorry, made a mistake. Okay, here's our line structure. 2 carbons and our OH, our alcohol group. Huh?
What did you say was wrong with the first time?
I drew an extra hump. I drew an extra carbon because I was just thinking of something. I was thinking of propanol instead of that. Huh?
So if you had like C3, H3, we'd have to draw more humps to the line structure.
Yes. Okay. Now, let's take a look at what our molecular formula would be.
C2.
And what else?
Oh,
Can it be reduced down any?
no.
So the molecular and the empirical formula are the same in that case. Okay? I'm going to give you another example, and that is propanol. Huh? Is this the one that's written differently in your book? There's one of them that your book is written incorrectly.
What was the alkyl halides that were written? Wait, why wouldn't that be CH3O
It's in your book. I should not be
for the empirical formula?
Because the oxygen can't,
Oh, it can't break down.
yeah,
Okay, so it has to have, to reduce anything, everything has to have a
yeah,
suffix or subscript.
yes.
So what's the empirical?
Remember lowest ratio.
So it'd be C3.
Nope, because this is a 1. You can't reduce it any further.
So it's the same thing.
If that
Yes.
would have been a 2 though, you could have broke it down.
Yeah, yeah.
Thanks, buddy.
Did I, okay, there's some chattering, so did I answer the question or not?
This one's
Is that going to be given to us, or do we have to memorize? Is what she was asking.
No, so it's like there's a specific way that we're supposed to find it, but Jody and Haley answered it. It's just a formula.
You're talking about that formula.
CH3CH2OH.
What you need to know is column 1, the family name. You need to know column 2, the functional group. You need to know, if I give you an example, I'm not going to say what is ethanol on this quiz. That'll be the next one. Okay? I'm not going to say what is ethanol, what is propanol. But if I give you a structure, you need to tell me that it is, if I were to give you this formula right here, you need to be able to say this is an alcohol.
No, that's not what I was asking. So this one.
No, are you asking me, are you going to need to know that ethanol is CH3CH2OH?
No, but it's okay.
No, but let me answer your question. I do not want to. You mean like, could you put CH2, CH?
They actually know that that's what it's supposed to use for, is that just a formula? Or you're supposed to look at something and realize that that's the formula.
Oh, yeah, that is the formula for ethanol, and you'll learn how to name that probably within the next couple pages. Did that answer your question? Okay. So, for example, this right here is propanol. And again, you'll learn, I think in this chapter coming up in the next few pages, you'll learn how to write like which one is ethanol, which one's propanol, which one's ethane, which one's propane, and so on.
So is alcohol the big picture and propanol is just a small product with alcohol, or are they the same level? Alcohol and propanol.
They are alcohols. They are different alcohols, but they are alcohols.
Wait, can you put like the R in the line OH?
You what?
I'm not talking to you.
Okay. To represent the functional group, you can put the R and the OH like I did up here. Now, there are millions of alcohols, or at least thousands of alcohols. And if, like later on in this chapter, you're going to be asked, write the formula for ethanol, write the formula for propanol. Well, there's a way to do that, but we're not there yet. Well, this is what we want to know are the functional groups. And so what I'm doing is I'm just giving you multiple examples. Does that make sense? Because your book gives you one example, but I'm going to give you a couple examples. Okay. Have I answered all the questions up to this point?
Yes, ma'am.
We're okay for right now? Okay. Now, the next one is an ether. An ether is going to have an oxygen in the middle of it. So your book draws it this way. Well, I say in the middle of it, but it doesn't have to be in the middle. It just has to be in between two other carbon chains. But an ether is an oxygen that is between these two carbon chains. An ether does not have a particular ending that goes on the end of it. An example that the book gives you is diethyl ether. I think this is the one where your book has a typo. Take a look at your book, and does it have the CH2 before the CH3 here? Because there's one of them where my other class said the book had something slightly different. Huh? Oh, sorry.
It has that.
The CH2 before the CH3?
No, it has to be running.
Yeah, CH3 then CH2.
Okay. There's one of them that everybody was saying the book was slightly different, so when we run across it, just let me know. Okay.
So ether will always have an oxygen in the middle.
Yeah. And I said middle, but it could be anywhere in that chain. Now remember, these things can go for 20, 40, 50, hundreds of carbons long. That's why we use R's. So that is this written with R's. Okay?
So if you put R, you don't have to do like a little
Yeah.
dash line.
If you're just showing the functional group.
Will you let us use that on our quiz?
If I say draw the ether functional group, this is acceptable. Okay. Now, if we were to draw the line structure for this, it would look like that. Let's go ahead and take a look at what that molecular formula would be. Okay, what about our empirical formula? Same thing on that one. Okay, and then again, the name that, this is just one example that your book gives you. So remember, for this quiz, we're focused on what are the functional groups. And then I think the next one, we probably pick up nomenclature, how to name these things. Huh?
So would you give us, like, the name of like diethyl ether we have to put in the group, or would you give us the formula that we have to put in the group?
I could say draw an example of an ether. I could say, I could give you this and tell me what is that, and you would have to tell me it's an ether. You don't have to tell me diethyl ether this time. I may not give you diethyl ether. I just may want you to recognize that this is an ether.
Could we do the ROR thing?
Yeah.
And it's still be right?
Well, yeah. See, remember, what is the point of this introduction? What is the whole point that I'm trying to help you to recognize at this point? The functional groups.
And their structure.
Right. And the structure of the functional groups, if there's a particular ending that you put on those functional groups, that's the point of this. Now, the next couple pages in the chapter after this, in your next quiz, will be putting all the names, like whether you use methyl, ethyl, propyl, whatever. Those come next. But the point of right now and the point of Thursday is knowing the functional groups, their symbols, how they would be named, like what if they have a suffix or something. Okay? Have I sufficiently answered those questions? Okay. And again, this is a memory thing. You're just going to have to memorize these functional groups. And one more time, again, I know my organic teacher pointed out a few of these, and then that was the end of it. This is it, one day, and moved on. So I know it's painful for you, but I am spreading it out over 3 days, and we will be, working with structures. The next one is an amine. Amines are very important. We see them in proteins all the time. That is something that makes up proteins. So if you think back to biology, amino acids, amines are going to have this functional group right here. A nitrogen with these two hydrogens. Now your book draws it like this. So I've just put an R there instead of having to draw it that carbon with the 3 lines. An amine is going to end with amine at the end of it. So they give you ethyl amine, that's the example that they give you, ethylamine. I'm going to make a bridge between last semester and this semester, something that could possibly cause you a little bit of confusion, and I want to try to nip it in the bud before it comes up to you. Okay? So make sure you're up and focused, because even though it is frustrating, you're going to be much more successful if you're paying close attention. Do you remember we have, this octet rule, right? And when we drew Lewis structures last semester, we had to show our lone pairs. So if you'll remember, nitrogen very frequently, like this is the ammonia molecule, and we showed that lone pair. If you look up here, when we're drawing this functional group right here, we're seeing these 3 bonds on this nitrogen. And this may look to you kind of not right, because when you count it, you're seeing 6 electrons around it. Do you see how what we learned last semester and this could cause you just a little bit of confusion? Remember that nitrogen, what were some of the valences that you wrote down yesterday that nitrogen's capable of having?
+3 and -3.
-5.
Okay, so you can see when we say that it has, you know, like 3 bonding sites, a valence of a positive or a -3, whatever charge it happens to be, here's our 3 bonding sites right there. Okay, so do y'all understand that? And I'm not reminding you this to confuse you, I'm just kind of reminding you this to, you know, going back and forth between stuff we did last semester and this semester. Okay. So let's just kind of forget that this is here and forget that I wrote it down. Okay, it's not there anymore. If you were to give me the molecular formula of ethylamine, what would it be?
C2H7N1.
Okay.
C2H7N1. Yeah. Exactly.
Yeah, C2H7N, or if you did happen to put your, no, yes, if you did happen to put your N1 there, I mean, that's fine. Okay, so those are amines. Amino acids are going to come from that functional group. Okay, aldehydes. Now an aldehyde has this functional group. It has this oxygen that is double bonded to a hydrogen here, and it ends with Al. Now, do not get confused between the Al for the aldehyde suffix and an OL for an alcohol suffix. It might be easy for you to be doing something real quickly and get confused about that. They give you ethanol, which is CH3 C. How do they write it on there? Oh yeah, COOH. They write it like this: O and H. If you were to write this as a line structure, let me show you something that's really important here on this line structure, and that is putting that double bond there.
bottom above the C
Double bond.
to the O.
Yeah. An aldehyde is doubly bonded to this oxygen with a hydroxide there. I mean with a, a hydrogen there. Okay. Now remember, this is ethanol, and it is not ethanol. What would ethanol have? An OH. Okay. Now, notice that it is also called acetaldehyde. Okay? Remember that long before IUPAC came along and long before we became a world economy, people had their own names for things. And there are some things that are just such a common part of our vocabulary, like this acid prefix here, like acetic acid. You're used to calling it acetic acid. If you're not used to calling it the IUPAC name. Okay? So there will be, just like in inorganic chemistry, there will be some just common names that we'll get used to seeing. Okay, the next one is a, this would be C2H4O, and then that would also be the empirical formula because it can't be reduced down any. All right. Then we're going to go on to a ketone. A ketone is going to have the suffix -one, O-N-E. A ketone is going to have, you know how an ether had an oxygen in the middle with a single bond? A ketone is going to have, hold on, I did that wrong. Don't write that down just yet. A ketone is going to have this carbon double bonded to an oxygen right here, and then stuff hanging off of both sides. This is a ketone. Now in the book, instead of using ours, they do it this way. And we're doing the same thing. Now they give you acetone, which is like your nail polish remover. And yes. Alright, so there's acetone, the example that they give you. When you draw a line structure, you're going to have, you've got 3 carbons, so you'll have a hump there, 1, 2, 3 carbons, and you've got to show that it's double bonded to that oxygen.
So in it's just nothing there. It shows it's just one bond, but when you draw both of those lines, that's when it shows it's two.
Double bond, yeah. Okay. So that's acetone. If we were to do the molecular formula for acetone, C3H6O, that would also end up being the empirical formula, right? All right. Let's take a look at a carboxylic acid. Okay, carboxylic acids are really important. If you look back at biology, when we deal with proteins, I don't know if you remember this or not, but proteins have three components to them. They have that R group, they have a carboxylic acid group, and they have that amine group. I don't know if you remember that from biology or not, but we'll be doing that again in here. But the carboxylic acid is this functional group. It has the ending oic acid here. Or I guess ic acid is. The book, instead of using R, shows you this. Don't get this confused with an aldehyde. An aldehyde just has a hydrogen here. This has an OH. They're going to show you acetic acid, if we draw a line structure for acetic acid, we've got carbon here, double bonded to an oxygen in the OH. Okay, this one is acetic acid. Yes.
But right there where it's the OH, there's not a carbon there though, is there?
No.
Because the OH is right there?
Yes. Yes.
When we have the earlier ones, how you had the line, it'd say it'd be just like CH3, CH2, and you wouldn't have no bonds or nothing attached to it. How come now you're trying to attach bonds to it?
Because here's the thing, your line structures do not show hydrogens unless they are part of that functional group. Now, the line segments show carbons, but now we're attaching like the OH and the A and the O because this is our functional group. We've got to show the functional group. It is understood universally that these lines are carbons. Yeah.
But like, so you're saying the carbon and the oxygen, like here it's the CH3C and you got the double bond of oxygen above it and then minus OH. That's separate from the line structure. We're at the same time.
Are you asking me what is this structure?
I'm asking you if the two those two parts are like connected together or are they two separate? They're separate. I know them being so well.
Are these connected? Is that what you're saying?
I'm talking about the line structure underneath.
Yeah, he's talking about, he's thinking that yeah.
Yeah. I didn't know if you're trying to connect the oxygen with the DH3 or something.
Oh, okay,
You know what
okay.
I'm saying?
Yeah. You were thinking they were one picture instead of two. Okay. Now, is that your bell? Okay, now I want you to take a look at where we are. Tomorrow, you'll finish the rest of those, and then your quiz on Thursday. Remember, the focus is on the functional groups. Their structures. Okay, give me seated and silent real quick, please.